All right, so we are going to move on to adding and subtracting rational expressions. We've talked about simplifying and multiplying. So just as when we talked about with multiplying and dividing rational expressions, adding and subtracting is kind of similar. So the procedures for adding and subtracting rational expressions are the same as those used to add and subtract fractions. So that means that two rational expressions with the same denominator can be easily added or subtracted. You just add the tops together, you add the numerators, and you keep the same denominator. Two rational expressions with different denominators are more difficult. So we need to find the least common denominator so that we can carry out the addition and subtraction. So I'm going to start off with this example here. We're going to first look at our denominators and we're going to check to see if they're the same, which they're both x plus 1 squared, which means that I can just go ahead and add my numerators. So when I add my numerators, I just do 4 plus 9 and get 13, and I keep the same denominator. And then there's nothing else that I can simplify, so this will be my final answer for that first one. If I look at number 2, however, I'm looking at my denominators again, and I have 4 and 3, and 4 and 3 are not the same number. So we need to do something to them to make them the same number. So I need to find my least common denominator that's 4 and 3. So what number does 4 and 3 both go into? The one that I can think of on the top of my head is 12. So how do I get to 12 from 3? Well, I multiply by 4. So if I multiply on 4 on the bottom, I have to multiply by 4 on the top. And then I think about how do I get to 12 from 4, and that's by multiplying by 3. So whatever I do to the bottom, I have to do to the top. So when I do this step, I'm going to go ahead and carry out that multiplication there, and I'm going to have 3x over 12 plus 8x over 12. And then again, I check to make sure that my denominators are the same. They're both 12. So now I can complete my addition. So I'm going to do 3x plus 8x, and 3x plus 8x is 11x all over 12. And then I can't simplify anymore. So this is going to be my final answer here. So I treated that just like I would if I had two fractions that don't have the same denominator. I have to find what's missing and how do I get to that number. So if I look at number 3 here, and I look at my denominators, they are not the same. They're really close, but I need to identify what I'm missing. So on this one, I have a 6, an a squared, and a b. On this one, I have a 9, an a, and a b squared. So 6 and 9, they have something in common. So I need to think about what's the least common factor, or what's the least common number between 6 and 9. And I would have to say it's probably going to be, let's see, 36. So my common number is going to be 36. It looks like I need to get up to an a squared. So I need an a squared on both of these guys, and I'm going to need a b squared on both of these guys. So that pink is what I'm trying to get to. So now I need to think about, well, what do I need to multiply these two by to get to 36? So starting with the first fraction, I need to multiply by 6 to get to the 36. And whatever I do on bottom, I have to do on top. To get to a squared, I don't have to do anything, but to get from b to b squared, I have to multiply by b. So on my first fraction, I'm going to multiply by 6b to get to 36. On my second fraction, I'm going to multiply by 4. And I need an a squared right now. I have an a, so I'm going to also multiply by an a here. So when I do that, I'm going to multiply everything out, make sure I got everything. So 6 times 5 is 30b all over 36 a squared b squared plus 2 times 4 is 8, and then I have that a over 36 a squared b squared. So then I check my denominators one more time. They're the same, so I can carry out my addition on the top. So I have 30b plus 8a all over 36 a squared b squared. So the last thing that I'm going to do is check to see if I can simplify anything else, which I can simplify one more thing. On the top, they both have 2 in common. So I could pull a 2 out and be left with 15b plus 4a all over 36 a squared b squared. Take it one step further and factor out that 2, and we would be left with 15b plus 4a over 18 a squared b squared. And that's going to be my final answer there. I'm going to move this guy down actually just so that I have room for my next one. So I end up with 15b plus 4a over 18a squared b squared. So now that I look back, I could have done multiplied by 2 and by 3 to get to 18. That would have been a smaller number. Sometimes it just takes trial and error to do it. I ended up multiplying by the number that I knew that they had in common for sure, rather than thinking of what was the smallest. But you should always try to think about the smallest. Sometimes you're not going to get it on the first try, and that's okay. You just have to make sure that you simplify, which is what I did to make sure that it was as small as possible. Because my last thing I'm going to do here is question myself, is 15, 4, and 18 have any numbers in common, which they don't. So I'm as simple as I can be here. So then I take a look at number 4 here. And I see I have x squared minus 4 and x minus 2. And those are not the same. So I need to do something in order to make these guys the same. Well, I see that that's an x squared, which means it's a quadratic, which should mean that I can factor it. So if I factor the denominator on that first one, I'm going to have x minus 2, x plus 2. Because I'm looking for 2 numbers that are going to multiply to give me -4, but are going to add to give me 0 there in the middle, which is -2 and +2. And I'll have my 3x on top, and then on my second fraction, I have 1 over x minus 2. So then I ask myself that question again of what am I missing? What am I missing? So they both have an x minus 2, but this one has an x plus 2 and this one doesn't. So that's what I'm going to multiply by. I'm going to multiply by x plus 2. I lost my x and my plus here. So I'm going to multiply my last fraction by x plus 2 on top and by on bottom. So when I do that, I get something that looks like 3x over x minus 2, x plus 2, minus x plus 2 over x plus 2, x minus 2. And then I can go ahead and do my subtraction here. So I have 3x minus 1x gives me 2x plus 2 all over x plus 2, x minus 2. And then I check to see if this is as simple as I can go, which this both have 2 in it, so I could factor out a 2 here. So if I factored out a 2, I'd be left with x plus 1 on the top and x plus 2, x minus 2 on the bottom. And there's nothing else that I can do, so I'm going to leave it just like that. You could leave it at the orange step if there's nothing else to factor, but I usually like to take it to as simple as I can go, just in case we're going to use this and multiply it by another rational expression, and then I could easily see where things would be able to cancel rather than having to factor things out again. So I have two more, and then I'll have some problems for you guys to do. So just like we did on the last one, we are going to have to do some factoring. So if we look at our denominators, these are not the same. So we need to factor our denominators and see if we get some like things going on. So the first one I'm going to factor is this one. So I need two numbers that multiply to give me -6, but add to give me 1. So I'm going to have my x on top, and then I need two numbers that multiply to 6, -6, but add to 1, which is x plus 3 and x minus 2. From here, I'm going to factor my second problem here, that denominator. So I have x plus 1 on the top, and then I need two numbers that multiply to give me 12, but add to give me 7. So that is x plus 3 and x plus 4. And then my next step here is to identify what I have that's the same and what I need. So here I have an x plus 3, I have an x plus 3. I need an x minus 2 and an x plus 4 for them all to be the same. So this one is missing the x minus 2. And this one is missing the x plus 4. So I need to get that to each one of those. So I'm going to do that multiplication here real quick. And I'm going to have x times x plus 4 all over x plus 4, x plus 3, x minus 2, plus x plus 1, x minus 2, all over x plus 4, x plus 3, x minus 2. And then I check my denominators again. These all have the same in them, which is good. We got what we wanted. So now we can just go ahead and carry out our multiplication or our addition here. So before we do that though, I think we're going to want to distribute some things first. So I'm going to do that distribution, and I'm going to have x squared plus 4x on the top over here. And I'm going to have x squared minus 2x plus x minus 2 over here. And then I'm going to look. So I have x squared and an x squared, and I'm adding them together. So I have 2x squared. And then I have a 4x, a 4x, a negative 2x, and a positive 1x. So I'm going to do 4 minus 2 is 2. And then 2 plus 1 is 3, so I have plus 3x. And then lastly, I don't have anything here that's a constant, but I do have this minus 2. So I'm just going to rewrite my minus 2 there. And that's all over my common denominator of x plus 4, x plus 3, x minus 2. Now I'm not completely done yet because I need to factor the top and see if I can pull anything out. So if you remember, when we have something that looks like this, I have to multiply a and c together. So when I do that, I'm looking for two numbers that multiply to give me -4, but are going to add to give me 3. So that's going to be 4 and -1. And then I'm going to split my numerator. So I'm then going to have 2x squared plus 4x minus x minus 2 all over x plus 4, x plus 3, x minus 2. And then we group these guys. So we're going to group this and then factor some things out. So when we do that, out of the first group, I can factor out a 2 and an x, and I would be left with x plus 2. And then out of the second group, I'm going to factor out that -1, and I would be left with x plus 2 as well. And that's all over my x plus 4, x plus 3, x minus 2. And then I'm going to continue down my page a little bit. So on top, we have 2x minus 1 as one factor, and x plus 2 is the other factor. And then we have x plus 4, x plus 3, and x minus 2. We can't cross anything out, so we leave it just like that. We leave it just like this. I know that that one seems a little bit longer. It's just because you have to factor so many times to get it as simple as possible. So sometimes they will be a little bit longer, but hang in there. They're not too bad. If you're confused on anything that I just did, please let me know, and I can go back over them with you during a Zoom conference. So this is the last one that we're going to do, and then I'm going to kind of let you guys work on your own. So we're going to look at our denominators. And again, we have to factor them. We have to do some work here. So we're going to multiply my A and C here. So I'm going to have two numbers that multiply to give me 6, but add to give me 5, -6, sorry. And that's going to be 6 and -1. So on the bottom here, I'm going to have 2x squared plus 6x minus x minus 3 all over my x plus 1. And let's see if I can squeeze in that other one in here. My other one, I'm going to multiply 2 and 1. And I'm going to have two numbers that multiply to give me 2 and are going to add to give me -3. So that would be -2 and -1. So here we're going to have 2x squared minus 2x minus x plus 1 all over x plus 3. So all I did was figure out what I needed to break that middle into. I broke it into my two groups, and now I'm going to factor them by grouping. So I'm going to group, 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 group. And then I'm going to do that factorization. So looking at my first set of parentheses here. So that first fraction, I have x plus 1 on top. And then below it, I can take a 2x out of the first part, and I would be left with x plus 3. And I can take a -1 out of that second set of parentheses, and I would be left with x plus 3 again, which makes me happy. I am going to do this over here, actually. So I can take a 2 out and an x out. X plus 3, -1, x plus 3. And then for this guy, I can take a 2 out and an x, so I'm left with x minus 1. Take out a -1, and you're left with x minus 1 again. So that means that I have this for my first fraction. And then I have this for my second rational expression. So the last thing I'm going to do is identify what I need for my denominators to be the same. So what do I need in order for my denominators to be the same? So I have a 2x minus 1 on both of them, but I'm missing an x plus 3 and an x minus 1 on both of them. So this one is missing the x plus 3, and this one is missing the x minus 1. All right. So let's do that multiplication here. And on top, we're going to have x plus 1, x minus 1, minus x plus 3, x plus 3. All over my 2x minus 1, x plus 3, x minus 1. All right. Let's go back through and remultiply some things out. So we're going to double distribute here. And if we do that, then we get x squared minus 1 minus x squared. Let me make this a little bit smaller so it'll all fit. We have x squared minus 1 for the first part, big minus x squared plus 6x plus 9 for the second part, all over my denominator. This is the most important part of this problem is you see this negative right here. Well, you need to make sure that when you redistribute this guy, that you leave it in parentheses because this negative has to go to every single one of them. So when we use our parentheses like that, so many steps, I'm so sorry. You should get something that looks like this. And then from here, this is when you can go through and you can say, okay, well, I have I have an x squared minus an x squared, so those are gone. And I have negative 1 minus 9, and I have a negative 6x. So we're going to leave the negative 6x because I don't have anything to combine it with. And we have negative 1 minus 9 gives me negative 10. All over all this other stuff. And sometimes it works out really nice where you can cross more out. This is not one of those times. You kind of just leave it just like this. I know that 6 and 10 both have a negative 2 in common, but we're not going to move any further than that. We're just going to leave it just like that. So I will post these notes along with the problems that you're going to have to do. So you're going to have 8 different problems to do. I might change it based on kind of the responses that I get, but I would say that the first 5 will go pretty smoothly, pretty quickly.